Today we're going to talk about using statistical experiments, and that's from 10.2 in the Reveal Algebra 2 book. And first, you need to understand the difference between theoretical and experimental probability. Theoretical probability is what we can fairly expect to happen. All right? Experimental probability is calculated using data from an actual experiment. And so, like if you're talking about flipping a coin, the theoretical probability of flipping a coin, well, there's heads and tails, so it'll be 1/2. The experimental probability of flipping a coin would mean like flip the coin 10 times, keep track of what happened. So you flip the coin 10 times and 7 times it comes up tails, then the experimental probability for tails is 7/10. And the experimental probability for heads would be 3/10 because it's based on the actual experiment that happened. Right? So that's the difference between theoretical probability and experimental probability. The penny game is something we would do in class if I was with you. And so let's look at this example. All right, this is a good explanation of theoretical and experimental probability. So a student tossed a fair. So fair just means it's balanced. It's not favoring any one side. And it's an 8-sided die. So it can be any number 1 through 8. And he rolled the dice 200 times and recorded what happened, he or she. Okay. And the rolls and what happened, that's recorded over here. It's called a frequency table. And then we want to find the theoretical and experimental probabilities of rolling an 8. Well, there's 8 numbers. One of them's an 8. And so you have a 1 in 8 or 12.5, or you say 0.125. Those are all different ways to write the theoretical probability, right, of rolling an 8. 8 happened 42 times of the 200 rolls. It was the most popular roll for some reason. And so it would be 42 over 200 would be the experimental probability, or you could reduce that to 21 over 100, or 21%, or 0.21. And so that's the difference between theoretical and experimental probability. And so this situation here, for example 1, the spinner is spun 400 times, and the results are shown. Find the theoretical and experimental probabilities of spinning a D. Write your answer as a percentage to the nearest tenth. Now, in this case, they're not all equal sizes. And so 25% or 1/4 of it is B. 20% of it is D. And so the theoretical probability isn't 1/6 because there's 6 letters. It's 20%, which you could say is 20 over 100. You could say it's 2/10, which is 1/5. Or you could say it's 0.20. The frequency is based over here. So the experimental data is based on how much it actually happened. And experimentally, D came up 82 out of the 400 times. And so I would take a calculator, or I could reduce it. But I'm just going to take a calculator, 82 divided by 400 is 20.5%. Right? 20.5%, or 0.205. Now, we can use things like rolling a dice, or spinning a spinner, or flipping a coin as a probability model. And so what is a probability model? A probability model is a mathematical representation of a random event. And so a simulation uses a probability model to imitate a process or situation so it can be studied. So that maybe we don't have the time to actually figure out, might really happen or count what really happened of a certain situation, but we know that situation has a certain number of outcomes. We can then use a probability model to see what could potentially happen with different scenarios. Right? And so, like, think of an instance of, when would flipping a coin be a good simulation? When would it be a good probability model to use for a simulation? Well, it's something that just has like two choices. Like maybe you and your buddy are deciding where to go eat for dinner. And one of you really wants to go to Burger King and the other one really wants to go to McDonald's, and you can't split the tie, and so you just flip a coin. 50-50 probability, one half, but like you could do an experiment to see, the possible outcomes. Not that that would be a great experiment, but that is at least an example of an experiment you could have for that situation. And so to conduct a simulation, and you're going to have to describe how to do it today. And so these are the steps you'd have to do. First, you have to figure out, okay, well, if the situation has 4 possible outcomes, is each one 1/4? Or maybe, one of them is, 20%, one of them is 30%, one of them is, 40%, one of them is only 10%. So you got to figure out, how likely is each thing theoretically to happen, and then describe a probability model. So, like if you have 6 things, but they're not all equally to happen, rolling a dice isn't good, because when you roll a dice, all 6 numbers are equally as likely to happen. Right? But if you have 6 things and they're all equally to happen, then rolling a regular dice is awesome because it has 6 sides and all of them are equally able to happen. Right? And then you define the trial of, why are you doing it, and state the number of trials. Number of trials, we want to make it as relevant as you can, and then you conduct the simulation and analyze the results. Right? And so what can I use for a simulation? We talked about just flipping a coin or rolling a die. You might have 6-sided die, 8-sided die. You might have a 20-sided die. There's different kinds of die. Right? Cards have 52 cards in a pack, so it can be used for all kinds of things. Or maybe you're just going to use the hearts cards. So you have 13 cards. So cards could be used. Right? Marbles could be used, and you have different colored marbles. They frequently, or chips, like poker chips could be used in that case. Something that you can count would be the instance of marbles here. A spinner, that just like we saw, you can create different size, pieces of the pie in the spinner, and so each spin is equal, like in the fact that you're spinning it fairly, but the different sections have unequal sizes. Or they have these things online usually, or an app for them called random number generators. Actually, there's one right built into your TI-84 as well. And so you're just going to have to describe which you would use. And so your problems are going to be like this. While creating a football app, a developer programmed one of his running backs to fumble on 5% of his carries. Design a simulation for the scenario. So the theoretical probability that he will fumble is 5%, which means 95% of the time he doesn't fumble, or she doesn't fumble. Right? And then they had you switch it to decimals. I might even say you might want to consider doing it as a fraction. Remember, if you're in class, you can type the decimal in and then hit math, enter, and it will change it to a fraction. And you also want to make sure you know, what does one spin count as here? One spin, one trial represents one carry. And so if you have a running back's going to have 100 carries in the season, you could spin it 100 times and get an experimental probability of how many fumbles that running back would have in the game. And I made the spinner there, and the spinner is a good way to go. You could also have done like chips, or maybe just write numbers, pieces of paper, and 20 pieces of paper, 19 of them are not a fumble. One of them is a fumble, and just draw out of a hat. I mean, there'd be all kinds of different ways. You're just going to have to explain how you would design a simulation. And that is what you're learning today. Good luck to you and have a great day.